Now you can see the definition of a matrices. A matrix is an arrangement of numbers in particular rows and columns. Usually it is denoted by a capital letter. Always the matrix is represented as a capital letter. Now suppose consider one example. Let us consider capital A is equal to 4, 3, 2, 1, 5, 6. Now clearly we can see that these are the elements of the matrices. Now see, these elements are written inside one box, that is a symbol of a matrix. And here we can see that this is the first row and this is the second row. Similarly, this is the first column, this is the second column and this is the third column. Okay, then now standard definition of a matrix. A matrix is an ordered rectangular array, that is arrangement. Array means arrangement of numbers or functions such as, now here also we can see one more example, and before that you can note the definition of a matrix. Take your notebook and write the definition of a matrix. Okay, write heading matrix. Then write a matrix is an ordered rectangular array, A-R-R-A-Y. In bracket you write that is arrangement of numbers or functions. Numbers or functions. The plural form of matrix is matrices. Okay. Now you write one more example. You write one example with this matrix, same matrix. Let capital A is equal to. We have already discussed that the matrices are represented using capital letters. Let A is equal to 1 sin x 3. Then second row x 4 0. Okay. These matrices are represented as capital letters. That is why I put the name capital A. And the elements of the matrices are always enclosed in the bracket. Enclosed in the bracket. This is a notation bracket or parenthesis. This is another symbol parenthesis, but mostly we are using the first symbol for the matrix. The members or functions of this matrix are called the elements or entries. That means here clearly we can see that these are the elements. What are the elements here? 1 is the element, sin x is the element, x is the element, 3 is the element, and also 0 is the element. Now here these elements, these are called the elements, or the members of the functions in a matrix are called the elements or entries of the matrix. Now here you write another definition. Write the elements of the numbers or functions of a matrix are known as elements. You note one more, write one more note. The numbers or functions in a matrix are called the elements or events. Now here also we can see that there are two types, that means two types of lines. There are horizontal lines and the vertical lines. Okay, horizontal lines and the vertical lines. These two, how many horizontal lines are here? Two horizontal lines are here. Two horizontal lines. First horizontal line is 1 sin x 3. The elements of the horizontal line is 1 sin x 3. And the second horizontal line, the elements of the second horizontal line is x 4 and 0. And these horizontal lines are called rows, R-O-W, rows of the matrix. And the vertical lines, what are the vertical lines? The elements of the vertical lines is 1x. First vertical line, and the second vertical line is sin x 4, and the third vertical line is 3 and 0. And the elements of these columns, that is known as columns. That is, the horizontal lines is known as rows and the vertical lines are known as columns. These are the horizontal lines and these are the vertical lines. Is called the column of the matrix. The matrix in the above example has, here in this we can see that clearly this is a 2 rows and 3 columns. Okay, did you clear? Now I am going to explain the second section, that is order of the matrix. Now you write the next heading, order of a matrix. Order of a matrix. Okay, now write the definition first. A matrix having m rows and n columns is called the order of the matrix, m by n. It is read it as m by n. Here it is, we can see that m into n, it is not read it as m into n, it should be read it as m by n, by by. Okay, so a matrix having m rows and n columns is known as the order of the matrix, and read it as m by n. Ready, clear? Now, let us consider the general form of an m by n matrix. Okay, general form of an m by n matrix. Now, what is the general form of an m by n matrix? General, let us consider the matrix. The name of the matrix we already discussed that it should be always denoted as the capital letters. So, let A is equal to A11, A12, A13, etc. A1n, A21, A22, A23, etc. A2n, etc. 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 The last row must be AM1, AM2, AM3, etc. AMN. Now see, this is a general form of a matrix. What it indicates A11. What is the meaning of A11? A11 means it is the first row, first element. Do you clear? First row, first element. What is the meaning of A12? A12 indicates first row, second element. First row, second element. What is the meaning of A13? A13 indicates the first row, third element. Do you clear? Similarly, what is the meaning of A1n? A1n indicates the first row, nth element. Okay? Now, similarly, what is the meaning of A21? Second row, first element. What is A22? Second row, second element. What is A23? Second row, third element. Etc. 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 We can see the last one. What is AMN? Nth row, nth element. Okay, so can you say the order of this matrix? Now here in this matrix, the total number of elements. Can you say how many elements are here? The elements are m into n. Mn elements are there. Or we can say that here it is how many rows? M rows and n columns. And the order is denoted as m by n. And it can be written as a compact form. The compact form of this matrix is capital A is equal to Aij, m by n, Aij. It is also denoted inside the matrix sign. Matrix sign Aij, m by n, where I lies between 1 and m and j lies between 1 and n. Ij belongs to the capital number letter n. That means natural numbers. The number of elements in m by n matrix is equal to mn. Okay. The element Aij in the ith row and the jth column, and it is called ijth element. So this is the definition, general definition of a matrix. Okay. Now we can discuss one example. Let us consider one example. Simple example we can take. Let A is equal to 2, 5, 6, first row. See, always you see what is the first row. This is first row, 2, 5, 6. Okay. And second row, 3, 4, 9. And the third row, 1, 8, 9. Similarly, we can see that, this is the first column, this is the second column, and this is the third column. Now, clearly we can see that, now altogether we can see how many elements are here? 9 elements are there, no? 3 rows and 3 columns, 3 into 3 is equal to 9. Now, our question is, there are 3 parts in the first question. First part. Write the order of the matrix. Now, I already said what is the order. Order means rows, columns. Rows by columns. How many rows are here? First row, second row, third row. 3 rows. How many columns are here? 3 columns. So, what is the order of this particular matrix? 3 by 3. So, the order of this matrix is 3 by 3. Did you clear? Then, the number of elements in the matrix that I already explained. How to find out the number of elements in m by n matrix? The number of elements in an m by n matrix is m into n, mn. Or here we have discussed m by n elements. Here it is 3 by 3 matrix. 3 by 3 matrix. How many elements are there? 3 into 3. That is 9 elements are here. Okay, so in this matrix total there are 9 elements. Now let us consider the third part of this question. Write A11, A13, A21, A23, A32, A33. Okay, now I am going to explain what is this A11, A11. What is A11 in this question? In this question, what is A11? A11 indicates what? First row, first element. I already explained. A11 means first row, first element. Now here in the first row, what is the first element? 2. So what about A11? A11 is 2. Did you clear? Similarly, you need to find out A13. A13 means first row, third element. First row, third element. This is the first row. Which is the third element? This is the third element. So what is A13? 6. Did you clear? Okay. Now, similarly, what is A21? A21 means the second row, first element. Second row, see, second row, first element. Second row, first element means this is the second row and this is the first element. In the second row, first element. So what is that? Now, similarly, 8 to 3. What is 8 to 3? Second row, third element. Second row, third element. What is that? 9. And A32. What is A32? Third row, second element. What is third row, second element? 8. Similarly, what is A33? Third row, third element. What is third row, third element? It is 13. Did you clear? Now you can write this question and answer it. I think you are already written the question now. Now write the question, note this question and answer this question. Now I will give you 1 minute for writing this question and answer. Okay. Now I think you are already completed, isn't it? No. Now we are going to discuss the types of matrices. Types of matrices. These are the important things in this matrix. Okay. And actually there are 7 types of matrices. Now first matrix is column matrix. What is that? Column matrix. The spelling you know. A-C-O-L-U-M-N. Column matrix. Column matrix. Now, what is the definition of column matrix? A matrix is said to be a column matrix if it has only one column. Okay? Column matrix means it has only one column. One column. One column is known as column matrix. Can you see an example? See the example of a column matrix. 1, 5, 3. See, clearly we can see that it is. How many columns are there? One column. One column. So, how many rows are here? Can you say the rows? 1, 2, 3. 3 rows. Okay, so can you say the order of this matrix? 3 by 1. In general, we can say that column matrix always having the number of columns is whatever the number of columns, that should be the number of columns is already 1, and the number of rows, whatever the number of elements, that should be the number of elements. That means here number of rows is 3, number of columns is 1. So the order of the matrix is 3 by 1. Or simply we can say that the column matrix means it has only one column. A one column matrix is column matrix. One column matrix means it has only one column. Similarly, let us consider. Write the definition. You write the definition of a column matrix. A matrix is said to be a column matrix if it has only one column. Now write one example. Example 1, 5, 3. You must note the order also. Here the order is 3 by 1. Now next type of matrix is row matrix. Write the next heading, row matrix. Now I already explained what is the meaning of a column matrix. The same way you can say what is the meaning of row matrix. Can you say what is the meaning of row matrix? A matrix is said to be a row matrix if it has only one row. If it has only one row. Example, one row. 1, 5, 6. So can you say the order? 1 by 3. Okay, order is 1 by 3. Write the definition. One row, 3 columns. That is 1 by 3. In the previous case, 3 rows, 1 column. That was column matrix. Column matrix, the number of columns should be 1, but in row matrix, the number of rows should be 1. That is a important fact. Now next, null matrix or zero matrix. What is the meaning of a null matrix or zero matrix? Now clearly we can see zero matrix means the elements should be 0. A matrix whose all elements are 0 is called a null matrix or a zero matrix. It's denoted as 0. Zero matrix means all the elements of this matrix is 0. Whatever the order. See, 0, 0, 0, 0. This is 0, 0, 0. 0, 0, 0, 0, 0, 0. The orders are different. Okay. The first one, what is the order? Can you say the order? It's a 2 by 2 matrix. In the second one, what is the order? 1 by 3 matrix. In the third one, what is the order? How many rows? 3 rows, 2 columns, 3 by 2 matrix. Now all these matrices we can see the elements is 0. So we can say that this is a 0 matrix and it is denoted as 0. 0 means a 0 matrix. Now let us take the fourth one. The fourth one is another important one, that is a square matrix. This is the most important definition. Square matrix means a matrix in which the number of rows are equal to the number of columns. Square means you know, the definition is understood. The length and breadth are equal in a quadrilateral. We can say that is a square, the same way. Here the number of rows and number of columns must be equal. Then we can say that that matrix is said to be a square matrix. See example. Any example you can take. Here I consider 1 and 2 by 2 matrix. 2 by 2 matrix. See 4, 5, 6, 9. So 2 by 2 matrix. 2 rows, 2 columns, square matrix. Similarly, we can consider 3 by 3 matrix, 4 by 4 matrix, etc. Okay. The general form of this matrix is, always the general form of the square matrix is capital A is equal to Aij. Aij. Not this general form. A is equal to Aij. M by M. See this M by M. This should be same. Number of rows and number of columns are same. That is why you write it as M by M. Order is M. Now write the definition. Okay, do you write? Now let us take the next definition, diagonal matrix. Diagonal matrix. Diagonal matrix is defined in the case of a square matrix. Okay, a square matrix, capital A is equal to Aij, is said to be a diagonal matrix if all its non-diagonal elements are 0. All its non-diagonal elements. See the word non-diagonal elements. See, this is the diagonal element. Diagonal. You know this is the shape of a square. You know how to draw the diagonal of a square? The same way this is the diagonal. All the non-diagonal elements are 0. The non-diagonal elements are, all the non-diagonal elements are 0. Only the diagonal elements, any number shall be there in the diagonal elements, and all the non-diagonal elements are 0 is called the diagonal matrix. And symbolically we can write, if Aij is equal to 0 when I not equal to j. What is the meaning I not equal to j? What happens if I is equal to 1 and j is equal to 1? 1, 1. 1, 1 means C. This is the first term, A1, 1. Now what about A2, 2? This. A3, 3, this. That means diagonal elements should be there, but the rest of the diagonal elements are 0. Okay. That is the meaning of a diagonal matrix. Now write the definition of a diagonal matrix. All the non-diagonal elements are 0. Non-diagonal elements are 0. Then we can say that it is a diagonal matrix. Do you clear? Now let us come to the next definition. I think all of you are written, no? Need more time? Okay, you can take 1 more minute. Okay, let us come to the next definition. Scalar matrix. Scalar matrix means a diagonal matrix is said to be a scalar matrix. See, first we define square matrix and then we define the diagonal matrix. We define diagonal matrix in the case of square matrix. Okay. Now we are going to explain the scalar matrix. Now we are going to explain the scalar matrix in connection with the diagonal matrix. See the series. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. The previous case we see that the diagonal non-diagonal elements are 0. The diagonal elements must be any number. But in this case, all the diagonal elements are equal. Diagonal elements must be equal. That is, a square matrix capital A is equal to Aij m by m is said to be a scalar matrix if Aij is equal to 0 when I not equal to j. Aij is equal to k. K means a constant, any constant when I is equal to j for some constant k. Now let us consider one example. After seeing the example, we can identify what is this. Let us consider the matrix as B. B is equal to root 3 0 0 0 root 3 0 0 0 root 3. See the speciality of the diagonal matrix DC. What about the diagonals? Diagonals, all the diagonal elements are constant. Here the diagonal elements are root 3 and the rest of the elements are 0. That is why we defined this matrix in the case of a diagonal. Okay. Scalar matrix is always in the case of defined always in the case of a diagonal matrix. Because now I am going to repeat this definition one more time. A diagonal matrix is said to be a scalar matrix. For the definition of a scalar matrix, we need to write a diagonal matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Okay, write the definition. The example also. You must write this definition and the general form with this pattern and also this example. Now, the next is identity matrix. Identity matrix. Now, you can see that in identity matrix, I write here 1. It is not 1, I. The representation of the identity matrix is capital I. Okay. Now, we can see what is the definition of an identity matrix. A square matrix in which, see, it's related with the square matrix. A square matrix in which the elements in the diagonals are all 1 and the rest are all 0 is called the identity matrix. That is, a square matrix capital A is equal to Aij m by m is an identity matrix if Aij is equal to 1, if I is equal to j, 0 if I not equal to j. It means what? A square matrix in which elements in the diagonals, all the diagonal elements are 1. Okay, all the diagonal elements are 1 and the rest of the elements are 0. Then we can say that that matrix is known as identity matrix. Write the definition. Example. Write this example also. 1 0 0 0 1 0 0 0. Not this example. Now I think all of you understood all these types of matrices, isn't it? If any doubt about the matrices, last 5 minutes you can ask me. Okay. Now I am going to explain the next one, equality of matrices. Equality. What is the meaning of equality of matrices? two matrices A and B. The standard form it is written A is equal to Aij and capital B is equal to Bij are said to be equal if two conditions must be satisfied. What are the two conditions? They are the same order. When we can say that the two matrices are equal? The two matrices are equal when they are of the same order. First. Then what is the second condition? Each element of A is equal to the corresponding element of B. See, what is the first condition? When we can say that the two matrices are equal? The first condition is that the two matrices are of the same order. Do you clear? The two matrices are of the same order. That means if you are considering a first matrix, it's of order 2 by 3. The second also must be the same order 2 by 3. Then only we can equalize the matrix. Okay? We can say that the two matrices are equal. Then what is the second thing? The second thing is that each element of A is equal to the corresponding element of B. That means what should be or what about the element of A11 in the first matrix? That is same as A11 in the second matrix. Or what is the element of A12 in the first matrix? That is also equal to, that is also same as A12 in the second matrix. Like that. Okay. Now, let us consider this example. For considering this example 2, 3, 4, 1 and 2, 3, 4, 1. See, clearly we can see what is the order of the first matrix? 2 by 2. Okay. What is the order of the second matrix? 2 by 2. What are the elements? See, first element 2, A11 is 2. Here also A11 2. A12 is 3. A12 is 3. A21 is 4. A21 is 4. A22 is 1. A22 is 1. So, for comparing, we can see that these two matrices are equal. Now, but what about these two? See, the order is same. This is of order 2 by 2. This is also of order 2 by 2. Do you clear? But see the elements. First element or A11 is 1. Here what is A11? 2. So, no need of looking in the others because see, our condition is not satisfied in this case. A11 is not same as A11. That means that the two matrices are not equal, it's unequal. Okay? Did you clear? Symbolically, if two matrices A and B are equal, we write A is equal to B. We write A is equal to B. Now, you note this definition first. Write equality of matrices. Write the definition and this example also note. No, write this definition and this example and the symbolic form also. Okay? Right. Okay, thing you have written. Okay, completed. Now, completed or not? I give one more minute. You can take 1 more minute for writing this definition. Okay, let us start exercise 3.1. Now all of you open your textbook and take exercise 3.1. The first exercise of this chapter, matrices. Now it is the third chapter, that is exercise 3.1. Okay, let us consider the first question. Write the question. In the matrix, write the question. In the matrix, capital A is equal to 2, 5, 19 minus 7, 35 minus 2, 5 by 2, 12. Root 3, 1, minus 5, 7. Not this matrix. Write this matrix. In the matrix, capital A is equal to now write the part of this question, the order of the matrix. Write the order of the matrix. Second part, the number of elements. And the third part, write the elements A13, A21, A33, A24 and A2. I think you completed this question, you written this question, no? Okay, I am going to explain. First, now see, how many rows are here? Rows. See, first row, second row, third row. How many rows are here? 3 rows. 3 rows. How many columns are here? First column, second column, third column and fourth column. That means this given matrix 3 rows and 4 columns. Did you clear? 3 rows and 4 columns. Now the first part is the order of the matrix. A matrix is having m rows and n columns is m by n matrix. That means row by column. So how many rows are here? 3 rows. How many columns are here? 4 columns. So what is the order of this matrix? 3 by 4. Understood? So the first part answer is 3 by 4. Did you clear? Now let us take the second part. A number of elements. A matrix of order m by n. Consider a matrix of order m by n. So how many elements are there in an m by n matrix? M by n matrix is having m into n elements. Okay. Now here it is 3 by 4 matrix. 3 by 4 matrix is having how many elements? 3 into 4. What is 3 into 4? 12. So the number of matrices, total number of matrices is equal to 12. Okay. The total number of matrices is equal to 12. Now let us consider the third part of the question. Write the elements A13, A21, A33, A24 and A23. Okay. Now let us consider A13. We can see what is A13. Now see the matrix A13. A13 means what? First row, third element. First row, third element. First row. This is the first row. What is the third element? First row, first element, second element, third element. What is the third element? 19. So the answer is 19. Now the second is A21. A21 means the second row, first element. The second row, first element. What is second row, first element? 35. Now similarly, what is A33? A33 means the third row, third element. What is the third row? This is the third row. What is the third element? First element, second element, third element. What is the third element? Minus 5. Did you clear? Now, A24. What is A24? Second row, fourth element. Second row, fourth element. This is the second row. Second row, first, second, third, fourth element. What is fourth element? 12. Did you clear? And similarly, what is A23? A23 means a second row, third element. Second row, third element, 5 by 2. Okay? Now, similarly, you can write all these answers. Write it. Not these answers. I think you completed this problem now. Now let us consider the second question. Okay. Question number 2. If a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? First you write the question. If a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? What if it has 13 elements? Okay, come back to this question. Here, how many elements are given in the matrix? The number of elements is given. That is the meaning of the question. You need to define the orders. So, how many elements are there in this particular matrix? 24 elements are there. 24 elements. So, how to find out the order of the elements? It is not only one. More than one is there. How to find out the order of the possible order of the matrices? Now, you know the number of elements is given as 24. Now, let us consider two numbers. Their product is coming as 24. In that way, we can define the order. Did you hear what I said? Now, the number of elements is given 24. Now, consider the two numbers. Their product is coming 24. What are the numbers? 124. You know, 1 into 24 is 24. Or 24 into 1 is also 24. Isn't it? Similarly, 2 into 12. 2 12s are 24. 12 into 2 is also 24. Then 6 4s are 24. 4 into 6 is also 24. Now, select the patterns of numbers. That is C. So, the order is 1 by 24, 2 by 12, 3 by 8, 4 by 6, 6 by 4, 8 by 3, 12 by 2, 24 by 1. Did you clear how to find out the order of the matrices if the number of elements is given? Number of elements is given. Let us take that a particular number and you select two numbers. The product is coming the number of elements. Okay. So, we can select, we can see that more than one element, more than one pattern is there. If in the case of a prime numbers, only 2 elements, 2 orders must be there. Because you know the prime numbers having only 2 factors, not more than 2 factors. So, let us consider 13. Now here one more, but if it has 13 elements, what happened if it has 13 elements? See, the best example, 13, what type of a number is 13? It's a prime number, no? Prime number, what are the factors of prime numbers? 1 and that number only, 1 and 13. So what are the orders? 1 by 13 and 13 by 1. So the possible orders are 1 by 13 and 13 by 1. No, not this answer. Okay, come to the next question. Question number 3. Let us take question number 3. Question number 3. If a matrix has 18 elements, what are the possible order it can have? A matrix have 18 elements, the same way. Now already I explained the second question. Okay, you can do the third question yourself because the same pattern is there. A matrix having 18 elements, what are the possible orders it can have? Now what if it has 5 elements? Now let us come to the first one. See, 18 elements. How many elements are there? 18. So let us collect the numbers or factors of numbers. So, let us consider 2 numbers. The product of 2 numbers is coming 18. What are the numbers? 1 into 18, 18 into 1, 9 2 or 9 2s are 18, 2 9s are also 18. Then what is the next one? 6 into 3. 6 3s are 18 and 3 6 are also 18. So what are the possible ways? The possible ways are 1 by 18, 18 by 1, 2 by 9, 9 by 2, 6 by 3 and 3 by 6. And the second part of this question is, what happens if the number of elements is 5? See, what type of a number is 5? 5 is a prime number. So how many factors are there in 5? 1 and 5. So can you say the possible orders? 1 by 5 and 5 by 1. Did you clear? That means if the number of elements is coming at prime number, it should be, that means the maximum number of possible orders is only 2. Similarly, now let us consider the next question, fourth question. Construct a 2 by 2 matrix. Now this is different question, okay? Construct a 2 by 2 matrix where A is equal to Aij, whose elements are given by Aij equals to I plus j the whole square by 2, Aij is equal to I by j, Aij is equal to I plus 2j the whole square by 2. 3 parts are there in this question, 3 parts. Now I am going to explain the first part. Consider the first part. See the question. Construct a 2 by 2 matrix. First you write the question. That's better. And not the question. Construct a 2 by 2 matrix. Capital A is equal to Aij, whose elements are given by, not the 3 parts. Then only I explain. Again, I think you written the question, no? Okay, come to the first question, first part. Aij equals to I plus j the whole square by 2. See, here the question is to construct a 2 by 2 matrix. So previous questions the matrix was given. But here you need to construct a matrix. The standard form is given. What is the standard form? Here Aij is equal to I plus j the whole square by 2. Okay. Now, you know the general form of a 2 by 2 matrix. What is the general form of a 2 by 2 matrix? The general form of a 2 by 2 matrix is A11, A12, A21, A22. That you know, no? Now our aim is to find out all these 4 elements separately. How to find out these 4 elements? A11 means instead of I you put 1 as I as 1 and J as 1. Then you will get A11. Similarly, how to write A12? A12 means put I is equal to 1 and J is equal to 2. Then you will get A12. Similarly, how to get A21? Put I is equal to 2 and J is equal to 1. Then you will get A21. Similarly, what is A22? I is equal to 2 and J is equal to 2. You will get A22. Now I am going to find out this things. See, put I is equal to 1 and J is equal to 1. So, what is A11? 1 plus 1 the whole square. Substitute these values of I and J in the given equation. What is given? I plus J the whole square by 2. 1 plus 1 the whole square by 2. What is 1 plus 1 the whole square? 2 square. What is 2 square? 4. 4 by 2. What is 4 by 2? 2. Now the first element is 2. Did you clear? Similarly, you find out what is the second element of the first row, A12. A12. I1, J2. I1, J2. Substitute the values of I and J in the given standard form. So, A21 is equal to I plus J the whole square by 2. That is 3 square by 2. What is 3 square by 2? 9 by 2. Similarly, what is A22? A22. Now, I is 2, J is 2. 2 plus 2 the whole square. What is 2 plus 2 the whole square? 2 plus 2 is 4. 4 square is 16. 16 by 2 is 8. Understood? Therefore, now we can write. Now, here in these values you can substitute here. A11, A12, A21, A22. Therefore, the required matrix is two, 9 by 2, 9 by 2, 8. Did you clear? A11, A12, A21, A22. This way we can construct a matrix. Similarly, let us come to the second question. Aij equals to I by j. This is the second question. Aij is equal to I by j. Okay. Now, here also the matrix is defined in the case of a 2 by 2 matrix. You need to form a 2 by 2 matrix. Okay. Now, first you write the standard form of a 2 by 2 matrix. The standard form of a 2 by 2 matrix is A11, A12, A21, A22. Okay. Then, as like in the previous case, substitute the values of I and j. A11 means what? I is 1, j is 1. That is I by j. What is I by j? 1 by 1. What is 1 by 1? 1. Similarly, what is A12? I is 1, j is 2. So 1 by 2. It's 1 by 2 itself. Similarly, A21. What is A21? I is 2, j is 1. So what is that? 2 by 1. It is 2. Now, how to find out the fourth one? A22. A22 is I is 2, j is 2. That is 2 by 2, 1. Now, write all these elements in the matrix. So, the required matrix is 1, 1 by 2, 2, 1. Now, write the answer. Now I think you completed this. Okay. Now one more part is there. You can do the question homework. Do it yourself because the same pattern is there. Now today I am going to wind up this section. Now you can see the next portion in the next class. Okay. Thank you.